Hello, in this lecture we will find out the size of line segment AE. In the drawing we have square ABCD. We know that angle BED, this angle is a right angle, it equals to 90 degrees. We also know that line segment EB equals to 2 units, line segment DE equals to 8 units, and we want to find out the size of line segment AE. So we connect together points A and E. We connect together points A and E by straight line. So we actually want to find out the size of the red line, the size of line segment AE. So in order to find out the size of line segment AE, we will join together points B and D by straight line. Actually, DB is the diagonal of square ABCD, but BD also, it is the hypotenuse of triangle EBD, because triangle EBD is a right angle, because this angle equals to 90 degrees. So we'll focus on the right angle triangle EBD. On the right angle triangle EBD, according to the Pythagoras theorem, the Pythagoras theorem states that in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse in the right triangle EBD is BD. So BD square will be equal to the sum, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, and the sum of the squares of the perpendiculars, it is actually EB square plus DE square. I will repeat again. In the right triangle BED, according to the Pythagoras theorem, DB square equals to EB square plus DE square, and so BD square equals to EB square. We know that EB equals to 2 units, so EB square is 2 square, 2 square is 4, plus DE square. DE equals to 8 units according to what is given as the question, so DE square is 8 square, 8 square is 64. So actually BD square equals to 64 plus 4 is 68. We will take a root out of equation number 1, and we will get that BD equals to the square root of 68. PD equals to the square root of 68. So BD, that is actually also the diagonal of square ABCD, it equals to the square root of 68. In the next step, I will present to you rule number 1. Rule number 1 states that the diagonals of a square bisect, of course it is the same thing, the same word, bisect the angles of a square the angles of the square into 45 degrees angles. I will read again rule number 1. Rule number 1 states that the diagonals of a square bisect the angles of the square into 45 degrees angles. So what is the meaning of rule number 1? The meaning of rule number 1 is that we know that all the angles inside a square are right angles, they are equal to 90 degrees, and the diagonals bisect the angles, that is to say, the diagonals creates angles that equals to 45 degrees because they divides the angle of 90 degrees to 2 equal parts, so each part will be equal to 45 degrees. So in our drawing we have diagonal DB of square ABCD, and according to rule number 1, the diagonal DB bisects angle ADC to 2 equal parts, that is to say this angle will be equal to 45 degrees, angle BDC equals to 45 degrees, and angle ADB will be also equal to 45 degrees according to rule number 1. Likewise, on the side, the diagonal DB bisects angle ABC, that is to say, it divides it to 2 equal parts. It means that angle CBD will be equal to 45 degrees, and angle DBABD will be also equal to 45 degrees. Okay? So we know that all the angles of a square are right angles, and therefore angle BCD will be equal to 90 degrees, and angle DAB will be also equal to 90 degrees. So we will focus on the right triangle DBC. In the right triangle DBC, DBC, cosinus 45 degrees equals to DC over DB. Okay, in the right triangle DBC, cosinus 45 degrees equals to DC over DB. We will define DC as y, that is to say DC equals to y. So cosinus 45 degrees equals to DC, and DC equals to y, so we'll substitute DC by y. And we have already found out that dB equals to the square root of 68. So in total we got that cosinus 45 degrees equals to y over square root of 68. We also know that cosinus 45 degrees equals to the square root of 2 over 2, and it equals to y over square root of 68. So here we will multiply equation number 2 by square root of 68, and we will get that square root of 2 over 2 times square root of 68 equals to y. So we found out that y equals to the square root of 2 over 2 times square root of 68. We know that 68 equals to 34 times 2, so we substitute 68 by 34 times 2. So y equals to square root of 2 over 2, and square root of 68 is the square root of 34 times 2. We have a rule that states that the square root of a times b equals to the square root of a times square root of b. So according to this rule, the square root of 34 times 2 will be equal to the square root of 34 times square root of 2, and we'll multiply it by square root of 2 over 2, and it equals to y, and this is actually question number 2. Here square root of 2 times square root of 2 is 2, so we write it down that y equals to 2 over 2 times square root of 34. 2 over 2 is 1, so 2 will get cancelled. And we actually found out that y equals to the square root of 34 units. Okay, so side DC of square ABCD equals to the square root of 34 units. But because of the fact that all the sides of a square are equal to each other, therefore all the other sides will be also equal to the square root of 34 units. BC equals to AB equals to square root of 34 units. Okay, in the next step I will present to you rule number 2, and we will implement rule number 2 in our drawing. Rule number 2 states that if a line segment AB subtends two equal angles on the same side, then quadrilateral ABCD is inscribed by a circle, and the 4 points A, B, C, and D lie on that circle. So I'll read rule number 2 again. Rule number 2 states that if a line segment AB subtends two equal angles on the same side, then quadrilateral ABCD is inscribed by a circle, and the 4 points A, B, C, and D lie on that circle. So what is the meaning of rule number 2? The meaning of rule number 2 is that if you have line segment AB So if you have this line segment AB, and two angles rest on this line segment AB. So we have angle, the first angle that rests on line segment AB is this angle, angle ACB rests on line segment AB, and it equals to theta. And we have also the second angle that also equals to theta that rests on line segment AB. So we have also angle ADB that also equals to theta and also rests on the same line segment AB. Okay? So if this is the situation, then according to rule number 2, the quadrilateral ABCD, this quadrilateral ABCD, this quadrilateral ABCD is inscribed by a circle. So as you can see from the drawing, quadrilateral ABCD is inscribed by this red circle, and the 4 points, point A, point B, point C, and point D, lie on this red circle. Okay? I repeat on rule number 2 again. Rule number 2 states that if we have two equal angles, those two equal angles that both rest on the same line segment AB, then according to rule number 2, the quadrilateral ABCD is described by this red circle, and the 4 points A, B, C, and D lie on this red circle. Okay? This is the explanation of rule number 2, and we can implement rule number 2 in our drawing. Why? Because in our drawing we have angle BED is a right angle, it equals to 90 degrees, and it rests on line segment BD, and angle BAD, it is also a right angle, and it is also rests on line segment BD. Therefore, according to rule number 2, the quadrilateral AEBD is inscribed by a circle. So this, the green quadrilateral AEBD is inscribed by a circle. Okay, according to rule number 2, the green quadrilateral AEBD is inscribed by a circle, and the 4 points A, E, B, and D lie on that circle. So we will actually draw this green quadrilateral inside a circle, inside this circle. It will be the implementation of rule number 2 in our drawing. So according to rule number 2, quadrilateral AEBD is inscribed by a circle. So we have here quadrilateral AEBD. So, as you can see from this drawing, quadrilateral AEBD is inscribed by this blue circle, and actually I copied this quadrilateral to here, so it will be also in green color, exactly as the origin quadrilateral. Quadrilateral AEBD is inscribed by this blue circle, we have here angle BAD that equals to 90 degrees. Angle BAD equals to 90 degrees. It is a right angle, and the second right angle is angle BED. Angle BED also equals to 90 degrees. So I will repeat on rule number 2 again, or I will repeat on the implementation of rule number 2. In this drawing, we have those two right angles, and they are both rest on segment line BD. Angle BED equals to 90 degrees, and it rests on line segment BD. Angle BAD also equals to 90 degrees, and it is also rests on segment line BD. It is exactly the same quadrilateral as here. Here we add those two right angles that rest on line segment BD, And here we also have the same two right angles that also rest on the same line segment BD. So, and according to rule number 2, if this is the situation, then this quadrilateral in the green color, quadrilateral AEBD, is inscribed by this blue circle, and the 4 points A, E, B, and D lie on this blue circle. So actually, this is the implementation of rule number 2 in our drawing. Okay? I will write it down that it is the implementation of rule number 2. Okay, this is the implementation of rule number 2. Because we add two right angles that rest on the same segment line BD, therefore according to rule number 2, the quadrilateral in the green color, quadrilateral AEBD, is inscribed by this blue circle, and the 4 points A, E, B, and D lie on this blue circle. Okay? So, in the next step, I will present to you rule number 3, and we will implement rule number 3 in our drawing, this drawing. So, according to rule number 3, if quadrilateral ABCD is inscribed by a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. So I will read rule number 3 again. Rule number 3 states that if quadrilateral ABCD is inscribed by a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. So what is the meaning of rule number 3? The meaning of rule number 3 is that if we have quadrilateral ABCD that is inscribed by a circle, so we have quadrilateral ABCD that is inscribed by this circle, As you can see from the drawing, the quadrilateral ABCD in the red color is inscribed by this blue circle, and we also know that the size of side AD of quadrilateral ABCD equals to A units. The size of side DC of quadrilateral ABCD equals to B units. The size of side BC of quadrilateral ABCD equals to C units. And the size of side AB of quadrilateral ABCD equals to D units. And we also know that diagonal AC equals to X units in its size. Diagonal AC equals to X units in its size. And diagonal BD equals to Y units in its size. So, according to rule number 3, whenever we have quadrilateral that is inscribed by a circle, we can implement rule number 3 in that drawing. So we have here quadrilateral ABCD that is inscribed by a circle. Therefore, we can implement here rule number 3. And according to rule number 3, the product of quadrilateral ABCD diagonals is X times Y, and that product equals to the sum of the products of its opposite sides. Quadrilateral ABCD has two pairs of opposite sides. The first pair of the opposite sides is actually side AB is opposite to side CD, and the second pair of the opposite sides is actually side AD is opposite to side BC. And the first product of the opposite sides, it is actually D times B. And the second product of the two other opposite sides, it is actually A times C. And the sum of the product of the opposite sides is D times B plus A times C. And that sum of the products equals to the product of its diagonals, that is to say it equals to X times Y, or the product of its diagonals, that is actually X times Y, equals to the sum of the products of its opposite sides, that is actually DB plus AC, or XY equals to DB plus AC. Okay, so that is actually rule number 3, and we will implement rule number 3 in our drawing. This is our drawing. First of all, why we can implement rule number 3 in our drawing? Because in our drawing we have quadrilateral AEBD in the green color that is inscribed by this blue circle. Whenever you have quadrilateral that is inscribed by a circle, you can implement rule number 3. Okay? So, according to rule number 3, the product of quadrilateral AEBD diagonals is AB times DE and that product equals to the sum of the products of its opposite sides. So the first product of the opposite sides is AE times DB, and the second product of the opposite sides, it is actually AD times EB, and the sum of the products of the opposite sides is product 1 plus product 2. Okay, the sum of the product of its opposite sides is AE times DB plus AD times AB, and that sum of the product of its opposite sides equals to the products of its diagonals, that is to say equals to AB times DE. I repeat again, the product of quadrilateral AEBD diagonals is AB times DE, and that product equals to the sum of the products of its opposite sides. The first product of the opposite sides is AE times DB. The second product of the other opposite sides is AD times EB. And the sum of the product of the opposite sides is product 1 plus product 2. That is to say, it equals to AE times DB plus AD times EB. And that sum of the product of the opposite sides equals to the product of quadrilateral AEBD diagonals, that is actually AB times DE. So the product of his diagonals, that is AB times DE, equals to the sum of the products of his opposite sides, that is actually AE times DB plus AD times AB. Okay, so that is equation number 3. And equation number 3 is the implementation of rule number 3 in our drawing. Okay, so I will copy again equation number 3, and we will put the data inside equation number 3 in order to find out the size of line segment AE. Okay, so equation number 3 states that AE, AB times AE, AB times DE equals to AE times DB plus AD times EB. So I actually copied equation number 3 to this page. This is equation number 3, that is the implementation of rule number 3 in our drawing. So now we will put the data inside this equation. So what is AB? AB equals to the square root of 34 units. Square root of 34 units. What is DE? DE is equals to 8 units according to what is given us in the question. So I repeat again that AB equals to the square root of 34 units. AB equals to the square root of 34 units, and DE equals to 8 units according to what is given us in the question, and all equals to AE. AE is the missing line segment, so we will leave it as it is. Times DB. DB equals to the square root of 68 units. I will repeat again. AE is AE, is the missing line segment. DB equals to the square root of 68 units. And what is AD? AD equals to the square root of 34 units. Times EB. EB equals to 2 units according to what is given us in the question. So I repeat again. AD equals to the square root of 34 units, and EB equals to 2 units according to what is given us in the question. So here we have 68. 68 is 34 times 2, so we write it down. we'll copy equation number 3 as it is, and we'll change only 68. Instead of 68, we will write down 34 times 2. Okay, and we will get that the square root of 34 times 8 equals to AE, and instead of 68 we write down 34 times 2 plus square root of 34 times 2. So we have the rule that the square root of a times b equals to the square root of a times square root of b, and according to that rule, the square root of 34 times 2 will be equal to the square root of 34 times square root of 2, so we write it down. And we will not change anything else. We will copy equation number 3 as it is. So here we divide the equation number 3 by square root of 34. So square root of 34 will get cancelled. And what is left after we cancelled square root of 34? What is left is actually 8 equals to square root of 2 times AE plus 2. So here we'll subtract 2 from equation number 3, this equation, and we'll get that 8 minus 2 is 6, equals to the square root of 2 times AE. We will divide this equation number 3 by square root of 2, and we will get that AE equals to 6 over square root of 2 so here we know that 6 equals to 3 times 2, so we write it down. AE equals to 3 times 2 over square root of 2 . So here we will multiply this expression by square root of 2, and then we will divide it by square root of 2, so we change nothing. Therefore this operation is allowable. So here we have in the denominator square root of 2 times square root of 2 is 2. So I write it down. AE equals to 3 times 2 times square root of 2 over 2. 2 over 2 is 1, so 2 will get cancelled. And we actually found out that AE the size of line segment AE equals to 3 times square root of 2 units, or in terms of numbers, AE equals to 4.243 units. So I'll repeat again. Line segment AE in the red color equals to either 3 times square root of 2 units, or in terms of numbers, line segment AE equals to 4.243 units. Okay, that is the answer to the question. Now I will summarize the lecture. Actually, we wanted to find out the size of this line segment AE, and in this drawing we have square ABCD. We know that line segment EB equals to 2 units, line segment DE equals to 8 units, and angle BED, this angle is a right angle, it equals to 90 degrees. And we want to find out the size of line segment AE, this line in the red color. Okay. So we actually connected points D and B by a straight line. This red line DB is also the diagonal of square ABCD, and it's also the hypotenuse of triangle BED. Triangle BED is a right angle because this angle equals to 90 degrees. In the right angle BED, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The square of the hypotenuse is dB square, and dB square equals to BE square plus DE square. I'll repeat again, in the right triangle, triangle EBD, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, dB square equals to EB square plus DE square. So dB square equals to EB square. EB equals to 2 units according to what is given us the question. So EB square will be equal to 2 square. 2 square is 4 plus DE square. DE equals to 8 units according to what is given us in the question. So DE square will be equal to 8 square. 8 square is 64. And 64 plus 4 is 68. So we found out that DB square equals to 68. We took a root out of this equation number 1, and we got that dB equals to the square root of 68 units. So we found out that the diagonal of square ABCD equals to the square root of 68 units. Then we also know that all the angles inside the square are right angles, so this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Then we focus on this right triangle, triangle DBC. In this right triangle, we know that cosinus 45 degrees equals to DC over DB. Okay, but before that, I actually presented to you rule number 1, and according to rule number 1, the diagonals of a square bisect the angles of the square into 45 degrees angles. So what is the meaning of rule number 1? The meaning of rule number 1 is that we know that all the angles inside the square are right angles, and according to rule number 1, the diagonals of a square bisects the angles of the square into 45 degrees angles. So because of the fact that every angle inside the square equals to 90 degrees, it makes sense that when you bisect 90 degrees, you will get each angle that equals to 45 degrees, because it divided to two halves. So every half will be equal to 45 degrees. So the diagonals inside the square bisects the angles, so we know that each angle equals to 90 degrees, therefore, because of the fact that diagonals bisect the angles, each angle will be equal to 45 degrees. This angle will be equal to 45 degrees, and this angle will be also equal to 45 degrees. Likewise, here we know that angle ABC equals to 90 degrees, and the diagonal DB bisects the angle, therefore this angle will be equal to 45 degrees, and this angle will be also equal to 45 degrees. So then we focus on the right triangle DCB or DBC. In this right triangle, we know that cosinus 45 degrees equals to DC over DB. Okay, cosinus 45 degrees equals to DC over DB. We define DC as y, that is to say DC equals to y. So cosinus 45 degrees equals to DC over DB, but DC equals to y according to our definition. So we substituted DC by y, and we already found that DB equals to the square root of 68 units. So in total we got that cosinus 45 degrees equals to y over square root of 68 units, and we know that cosinus 45 degrees equals to square root 2 over 2, and we got that square root over 2, square root of 2 over 2 equals to y over square root of 68. We multiplied the equation number 2 by square root of 68, and we found out that y equals to the square root of 68 times square root of 2 over 2. We know that 68 equals to 34 times 2, so we substituted 68 by 34 times 2, and we got that y equals to square root over 2 times square root of 34 times 2. And we have the rule that states that the square root of a times b equals to the square root of a times square root of b. Therefore, the square root of 34 times 2 will be equal to the square root of 34 times square root of 2 according to this rule. So in total we got that y equals to the square root of 2 over 2 times square root of 34 times square root of 2. Square root of 2 times square root of 2 is 2. So in total we got that y equals to 2 over 2 times square root of 34. 2 over 2 is 1, so 2 will get cancelled, and we found out that y equals to the square root of 34 units. So this side of the square equals to the square root of 34 units, but because of the fact that all the sides of a square are equal to each other, therefore all the other sides will be also equal to the square root of 34 units. Okay, then I presented to you rule number 2. According to rule number 2, if a line segment AB subtends two equal angles on the same side, then quadrilateral ABCD is inscribed by a circle, and the 4 points A, B, C, and D lie on that circle. So what is the meaning of rule number 2? The meaning of rule number 2 is that if we have line segment AB, this line segment, and we have two equal angles that subtend or rest on this line segment AB. Angle ADB rests, that equals to theta, rests on line segment AB, and angle ACB that also equals to theta rests on the same line segment AB. Therefore, according to rule number 2, the quadrilateral ABCD, this quadrilateral is inscribed by this red circle, and the 4 points A, B, C, and D lie on this red circle. So whenever you have quadrilateral, whenever you have a line segment, any line segment, the two equal angles rest on that line segment, then according to rule number 2, the quadrilateral that is created by the line segment and the quadrilateral that is created by the line segment and the two angles is inscribed by the red circle. In this case, is quadrilateral A, B, C, D is inscribed by red circle, and the 4 points A, B, C, and D lie on that red circle. And actually, we implemented rule number 2 in our drawing, because in our drawing we have two right angles. Angle BED is a right angle, and it rests on line segment DB. Angle BAD is also a right angle, and it also rests on the same line segment BD. Therefore, according to rule number 2, the quadrilateral AEBD in the green color is inscribed by a circle, and the 4 points A, E, B, and D lie on that circle. And this drawing is the implementation of rule number 2 in our original drawing. Why? Because according to rule number 2, because of the fact that we have two right angles, that they are both subtend on the same line segment DB, therefore according to rule number 2, the green quadrilateral AEBD is inscribed by this blue circle, and the 4 points A, E, B, and D lie on this blue circle. Okay, so this drawing is the implementation of rule number 2 in the original drawing. Okay, after we implemented rule number 2 in the original drawing, we arrived to this drawing. Okay, then I presented to you rule number 3. Rule number 3 states that if quadrilateral ABCD is inscribed by a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. So, what is the meaning of rule number 3? The meaning of rule number 3 is that whenever you have quadrilateral that is inscribed by a circle, like in this drawing, we have quadrilateral ABCD that it is inscribed by this blue circle, we can implement rule number 3 in that drawing. So whenever you have quadrilateral that is inscribed by a circle, you can implement rule number 3 in that drawing. Okay, so here we have quadrilateral ABCD that is inscribed by a circle, and so we will implement rule number 3, and according to rule number 3, the product of its diagonals, that is actually x times y, equals to the sum of the products of its opposite sides. And the sum of the product of its opposite sides, actually quadrilateral ABCD is two pairs of opposite sides. Side AB is opposite to side CD, and the second pair of the opposite sides is actually side AD is opposite to side BC, and the first product of the opposite sides is B times D. The second product of the opposite sides is A times C, and the sum of the product of the opposite sides is DB plus AC, and that product equals to the product of its diagonals, that is actually x times y. I will repeat again, the product of quadrilateral ABC diagonals is x times y, and it equals to the sum of the products of its opposite sides, that is actually BD plus AC. Okay, and we actually implemented rule number 3 in our drawing. First of all, why we can implement rule number 3 in our drawing? Because in our drawing we have the green quadrilateral AEBD that is inscribed by the blue circle. Therefore, whenever you have quadrilateral that is inscribed by a circle, you can implement rule number 3. Okay, and according to rule number 3, the product of quadrilateral A, B, A, E, B, A, E, B, D diagonals is AB times DE. AB times DE is the product of quadrilateral AEBD diagonals, and it equals to the sum of the products of its opposite sides. And the sum of the products of its opposite sides, the first product of the opposite sides is AE times BD, AE times BD, and the second product of its opposite sides is AD times EB, and the sum of the products of its opposite sides is product 1 plus product 2. And so the sum of the product of its opposite sides, that is AE times BD plus AD times BE, equals to the product of its diagonals, that is actually AB times DE. Okay, I repeat again, the product of quadrilateral AEBD diagonals is AB times DE, and it equals to the sum of the products of its opposite sides, that is to say, it equals to the first product of the opposite side, that is actually AE times BD, plus the second product of the opposite sides, that is actually AD times EB. Okay? And then the only thing that is left to do is to put the data inside this equation. I repeat again that equation number 3 is the implementation of rule number 3 in our drawing. Okay, so we will put the data inside equation number 3. I copied again equation number 3. Actually, AB equals to the square root of 34. DE equals to 8 units according to what is given as the question. AE is the missing line segment. DB equals to the square root of 68. And AD equals to the square root of 34. And EB equals to 2 units according to what is given as the question. Then I copied this equation number 3 here, and we change only this expression. 68 equals to 34 times 2. So we substitute 68 by 34 times 2. And we have the rule that the square root of A times B equals to the square root of A times square root of B. Therefore, the square root of 34 times 2 will be equal to the square root of 34 times square root of 2. Okay, so we copied equation number 3 as it is. We change only this expression. Okay, square root of 34 times 2 equals to the square root of 34 times square root of 2 according to the rule that I mentioned. Then we divided this equation by square root of 34, and so square root of 34 get cancelled, and what is left after we cancel square root of 34, what is left is it is actually 8 equals to the square root of 2 times AE plus 2. We subtracted 2 from equation number 3, and we got that 8 times 2 is 6. 6 equals to the square root of 2 times AE. We divided equation number 3 by square root of 2, and we got that AE equals to 6 over square root of 2. 6 equals to 3 times 2. So we substituted 6 by 3 times 2, and we got this equation number 3, that AE equals to 3 times 2 over square root of 2. We multiplied this expression by square root of 2, and then we divided it by square root of 2, so we changed nothing. And here, so we got that A equals to 3 times 2 times square root of 2 over square root of 2 times square root of 2. Square root of 2 times square root of 2 is 2. So we got that A equals to 3 times 2 times square root of 2 over 2. 2 over 2 is 1, so 2 will get cancelled. And we found out that AE equals to 3 times square root of 2 units. Or in terms of numbers, AE equals to 4.243 units. I repeat again, we found out that the line segment AE in the red color equals to either 3 times square root of 2 units or in terms of numbers, line segment AE equals to 4.243 units. Okay, so that is the answer to the question. Okay, thank you very much.